This is the first practice quiz for quiz 3 in Algebra 2. So the first part of this is the basic parts of solving right triangles. So you're going to use the Pythagorean theorem on 1 and 2. And remember, trace the right angle. That's what you're doing. Trace it out. So 6.5 squared plus x squared equals 9.9 squared. And then you are doing the work, okay? Crunching those out, getting x squared on one side, and then square rooting that answer to see what you get. So this would be x squared is 109. So x is 10.4. So you want to isolate the isolate x squared. Okay, so here x squared is 9.9 squared minus 6.5 squared, 55.76. And then you square root that and you get 7.5. And please do that accurately and round it accurately to the nearest tenths place. Problem 3 is all about stating these ratios correctly. So you're going to want to set it up for t first of all. There's for t, so sine of t is 7/25. Cosine of t is 24/25. And tangent of t is 7/24. Now let me show you a little trick here. So the cosine of one of the acute angles is the sine of the other one. So the sine of C is 24/25. Now you can reset it and check it out. So the cosine of C is the sine of T, 7/25. And then the tangents flip around like so. But if you need to, just go ahead and redo this, flip the A and the O around, and then you will see how all that comes about. This whole page is about solving for a missing side or a missing angle using right triangle trig. Okay, adjacent, hypotenuse, opposite. So this is going to be a sine because we have the O and the H with the 14 and the X on. So sine of 52 equals 14/x. And when you take the cross product and divide, equals 14. X is 14 divided by sine of 52. And that is 17.8. Okay, here, adjacent, hypotenuse, opposite. This is going to be a cosine. So cosine of 49 equals x/20. And when you do the cross product here, you do not have to divide. And this is going to be 13.1. So I'm not taking too long in this video. I'm going to be going a little bit faster, with the work that I assume that you know, and stick to the part that I might need to spend a little more time on. So here we're finding an angle. You can't use angle sum. So this is the sine ratio, and I'm only going to show this once. So you're going to take the sine inverse of both sides. Okay, so you didn't need the over one by there, by the way. I'm just so used to doing that. Sine inverse, that knocks that out. And so sine inverse of 19/27. And that's about 45 degrees. To the nearest degree, please. So you just need to, so this is adjacent, hypotenuse. Got to be careful. The sides that make the angle you pick are A and H, with the A making the right angle. So I'm going to tip them all away, flip them around. You need to know that concept. So this is tangent. So it's going to be tangent inverse of opposite over adjacent, TOA, in the abbreviation, so ka TOA, O divided by A. And that's 53 degrees. Okay, some more problems here. So this is basically, you have the ladder. Here's the wall, 20 feet long. This is 57. What is X? Okay, so we have adjacent, hypotenuse, opposite. So this is going to be a cosine setup. Cosine of 57 equals X over 20. So X is 20 times cosine of 57. And that is 10.9 feet, of course. Two joggers run 8 miles north and 5 miles west. I'll try to be a little bit more to scale this time. So 8 miles north and 5 miles west. How far are they? Do they need to come back to their starting point? So trace the right, this is a Pythagorean theorem problem, trace the right angle. So this is 8 squared plus 5 squared. Remember, you want to isolate the squared variable and then square root that, 9.4 miles. All right, 30, 60, 90 rules to finish this out. So you just need to look at, so here we go. This is your 2x. This is your x, and this is your square root of 3x. So the y side here must be double. So this is 16. And then this is 8 times the square root of 3. This side here. So y is 16 and z is 8 times the square root of 3. And here, so this is x, and square root of 2x. Well, you can tell by looking at this that that's got to be 5. X has to be 5. So I'm going to make this pretty simple. And you go with the original. So y is that original label. Anyway, try to go with these because that's how the SAT is going to present them to you. And of course, some tier 3 questions here. So what we want to know is the length of this diagonal. Well, here we go again, Pythagorean theorem. Trace the, you can call that whatever you want. Trace the right angle. So 72 is x squared, and then square root that, 8.5 feet. So the person that's building this would have to measure 8.5 feet in both diagonals to square that up. So that's actually a building thing, believe it or not. All right, so we want to know what point C is here. See, obviously you can tell that 5 is the x. I'm going over 5 and then up so many. No, let me stop that. No. All right, so what we have to do is we have to solve this right triangle here. And this is one I put on here. So this is 72. We're not going to be able to use 30, 60, 90 rules. Once we get these sides, so it's not going to be 5. Once we get these sides, so we're solving this right triangle here. 4, 72. This is side X and this is side Y. Then we'll have the coordinates of point C. So you can see again that you have, this is adjacent, hypotenuse, opposite. So cosine 72 is x over 4. That's one thing you can do. And to get the y, you can use sine 72 equals y over 4. And so when you solve for x and y, you'll get 5.2. Again, I'm not going to do all that workout. That's something you should know. And then y is 3.8. So 5.2, 3.8 are the sides, because that's the, once we look at this angle, we got the 72 from 180 minus 108. That's how we got that. You need to solve those two. These get a little bit different. So the right triangles you solve involve 30, 60, 90, 45, 45, 90 rules on the later versions of the practices. All right, and here is the spiral. So I encourage you to do the spiral. It's something that you can, it's like having another quiz grade add an A. So the degree here is the highest power. The leading coefficient is the coefficient on that highest powered term, and the y-intercept is the number at the end. Write an equation for the function y equals x to the third that has been shifted 5 units down. So I'm going to do this in my head now instead of doing those transformation substitution tables. 5 units down, so y plus 5 has to go in for y, and 3 units right. So x minus 3 goes in for x, because this is x plus 3, and this is y minus 5. So you put the opposite in, and then just solve. Now I'm not going to make you cube this out or go and look that. You could, but that's not the point with that. Okay, and then 16, solve by factoring, show all your work. So this is where you can go and get these two with the root finder, the math portal, the root finder, and then just turn these into factors. And then the extra work is you got to put them equal to 0. So that's what I really teach when I teach factoring. So I'm actually giving you these and you're going backwards. So reverse solving is how I teach factoring. So that's what we're going to do here. We're going to get these and then go backwards. You could also do the factoring by sight. Two numbers that multiply to 12 and add to 7 at the same time, 3 and 4. In other words, you can do the reverse FOIL, but you do have to show this. This is the work here. Okay, and that is practice quiz 1 for the third quiz in Algebra 2 in the second try.